Good day, everyone. I will be presenting to you systems implementation, operation, and support. After studying this chapter, we should be able to describe the process of coding, testing, and installing an organizational information system and outline the deliverables and outcomes of the process. Apply four installation stages: direct, parallel, single location, and phased installation. List the deliverables for documenting the system and for training and supporting users. Compare the many modes available for organizational information system training. Discuss the issues of providing support for end users. Explain why systems implementation sometimes fail. Explain and contrast four types of maintenance, and then describe several factors that influence the cost of maintaining an information system. Now let us proceed. The implementation and operation phase of the system's development life cycle is the most expensive and time-consuming phase of an entire life cycle. This phase is expensive because so many people are involved in the process. It is time-consuming because all of the work that has to be completed through the entire life of the system. During implementation and operation, physical design specifications must be turned into working computer code. Then the code is tested until most of the errors have been detected and corrected. The system is installed, user sites are prepared for the new system, and users must come to rely on the new system rather than the existing one to get their work done. Even once the system is installed, new features are added to the system. New business requirements and regulations demand system improvements, and corrections are made as flaws are identified from the use of the system in new circumstances. These changes will have ripple effects, causing a rework in many systems development phase. The seven major activities we are concerned with in this chapter are coding, testing, installation, documentation, training, support, and maintenance. These and other activities are highlighted in the figure below. Our intent is not to explain how to program and test systems. Most of you already have learned about writing and testing programs in other courses. Rather, this chapter shows you where coding and testing fit in the overall scheme of implementation and stresses of the view of implementation as an organizational change process that is not always successful. In addition, you will learn about providing documentation about the new system for the information systems personnel who will maintain the system. Likewise, you will learn about providing documentation and conducting training for the system's users. Once training has ended and the system is accepted and used, you must provide a means for users to get answers to their additional questions and to identify needs for further training. Your first job after graduation may be well as a maintenance programmer or an analyst. Maintenance can begin soon after the system is installed. A question many people have about maintenance relates to how long organizations should maintain a system: 5 years, 10 years, or longer. This question has no simple answer, but it is most often as an issue of economics. In other words, at what point does it make financial sense to discontinue updating an older system and build or purchase a new one? Upper Information System Management gives significant attention to assessing the trade-offs between maintenance and new development. In this chapter, we describe the maintenance process and the issues that must be considered when maintaining systems. At the end, we describe the process of resolving a maintenance request at Pine Valley Furniture. Now, for system implementation and maintenance, it is composed of seven major activities: coding, testing, installation, documentation, training, support, and maintenance. The purpose of this is to convert the physical system specifications into working and reliable software and hardware, document the work that has been done, and provide help for current and future users and caretakers of the system. Usage of the system leads to changes, so during maintenance, users and others submit maintenance requests. Requests are transformed into specific changes to the system. The system is redesigned to accept the changes, and the changes are implemented. These steps are often done by other project team members beside analysts. Although analysts may do some programming and other steps, often a separate analyst and developer team from those who develop the original system is responsible for testing, documenting, training, and maintenance activities. In any case, analysts are responsible for ensuring that all of these various activities are properly planned and executed. We briefly discussed these activities in three groups. Number one, activities that lead to the system going into operation, coding, testing, and installation. Number two, activities that are necessary for successful system operation, that is documenting the system and training and supporting users. Number three, activities that are ongoing and needed to keep the system working up to date and maintenance. The process of coding and testing and installation. Coding, it is the physical design specifications and are turned into working computer code. Testing, tests are performed using various strategies. Testing can be performed in parallel with coding. Installation is the process during which the current system is replaced by a new system. Coding, testing, installation, and deliverables. Action. Coding, well, the deliverable for coding is the code or program documentation. Testing, test scenarios, test plan, and test data, results of the program and system testing. And installation, user guides are the deliverables, training plans, installation, and conversion plan. Increasingly, automated tools are used to maintain the documentation needed by system professionals. The result of program and system testing are important deliverables from the testing process because they document the tests as well as the test results. For example, what type of test was conducted? What test data were used? How did the system handle the test? The answers to these questions can provide important information for system maintenance, as changes require testing and similar testing procedures will be used during the maintenance process. The next two deliverables, user guides and user testing plan, result from the installation process. User guides provide information on how to use the system or the new system, and the training plan is a strategy for training users so they can quickly learn how to use the new system. The development of the training plan probably began earlier in the project, and some training on the concepts behind the new system may have already taken place. Now, during the early stages of implementation, the training plans are finalized and training on the use of the new system. Similarly, the installation plan lays out a strategy for moving the old system to the new. Installation includes installation system, hardware and software at central and user sites. Now moving on. We have several software quality problems. Number one, inaccurate requirements, design problems, coding errors, faulty documentation, and ineffective testing. Now we have 5 maturity levels. Initial, the software process is characterized as ad hoc, maybe even chaotic. Few processes are defined, and success depends on individual efforts and heroics. Repeatable, basic project management processes are established to track cost, schedule, and functionality. The necessary process discipline is in place to repeat earlier successes on projects with similar applications. Define. The software process is documented, standardized, and integrated. All projects use and approve tailored versions of the organization's standard software process for developing and maintaining software. Manage. Detailed measures of the software process and product quality are collected. Both the software processes and products are quantitatively understood and controlled. Optimizing. Continuous process improvement is enabled by quantitative feedback from the process and from piloting innovative ideas and technologies. For software application testing, a test plan is developed during the analysis phase. During the design phase, a unit test plan, an integration test plan, and a system test plans are developed. The actual testing is done during implementation. The test plans provide improved communication among all parties involved in the testings. Serves as checklist. In the types of testing, we have inspection, meaning a testing technique in which participants examine program code for predictable language-specific errors. Next is walkthrough, a peer group review of any product created during the system's development process, also called a structured walkthrough. Next, desk checking, a testing technique in which the program code is sequentially executed manually by a reviewer. Next, we have unit testing. Unit testing where each module is tested alone in an attempt to discover any errors in its code, also called module testing or modular testing. Integration testing, meaning the process of bringing together all of the modules that a program comprises for testing purposes. Modules are typically integrated in a top-down incremental fashion. Sub-testing, stub testing, a technique used in testing, especially where modules are written and tested in a top-down fashion, where a few lines of code are used to substitute for subordinate modules. For system testing, this tests the requirements, usability, security, and documentation. For the testing process, number one, the purpose of the testing is confirming that system satisfies requirements. Number two, testing must be planned. A test case, a specific scenario of transactions, queries, or navigation paths that represent a typical, critical, or abnormal use of the system. Test cases and results should be thoroughly documented so they can be repeated for each revision of an application. Acceptance testing by users. Alpha testing. User testing of a completed information system uses simulated data. Recovery testing forces the software or environment to fail in order to verify that the recovery is properly performed. Security testing verifies the protection mechanisms built into the system will protect it from improper penetration. Stress testing tries to break the system. Performance testing determines how the system performs on the range of possible environments in which it may be used. Beta testing. This user testing of a completed information system using real data in the real user environment. Installation. The organizational process of changing over from the current information system to a new one. There are four approaches to installation. Number one, direct installation. Changing from the old information system to a new one by turning off the old system when the new one is turned on. Parallel installation. Running the old information system with the new one at the same time until management decides the old system can be turned off. Single location or pilot installation. Trying out an information system at one site and using the experience to decide if and how the new system should be deployed throughout the organization. Phased installation. Changing from the old information system to the new one incrementally, starting with one or few functional components and then gradually extending the installation to cover the whole new system. Planning installation. There are considerations. Number one, data conversion. We are looking for error correction and loading from current system. Then we have planned system shutdown and business cycle of organization. Let us now move on to documenting the system, training users, and supporting users. Number one, two audiences for documentation. The information systems personnel who will maintain the system throughout its productive life, and the people who will use the system as part of their daily lives. The deliverables, documentation. We have system documentation and user documentation. User testing plan, we have classes and tutorials. User training modules, the training materials, computer-based training aids. User support plan, we have help desks, online help, bulletin boards, and other supporting mechanisms. Documenting the system, detailed information about a system's design specifications, its internal workings, and its functionality. For internal documentation, system documentation that is part of the program source or code is generated at compile time. For external documentation, we have system documentation that includes the outcome of the structured diagramming techniques, such as data flow and entity relationship diagrams and data dictionary entries. For user documentation, we have reference documents to perform a specific function, procedures manuals to perform a business tasks or several functions, tutorials to use major components of the system designed to be read in sequence, training information system users. Potential training topics, we have several. Use of the system, general computer concepts, information system concepts, organizational concepts, system management, and system installation. Training methods. We have resident expert, computer-aided instruction, formal courses, software help components, tutorials, interactive training manuals, external sources such as vendors. We have electronic performance support system or EPSS, component of a software, package, or application in which training and educational information is embedded. With supporting information system users, support is extremely important to users. JD, for example, JD Power and Associates survey found user support to be number one criterion contributing to user satisfaction with personal computing. Most organizations provide support by two means: information center and help desks. Install a new software or hardware and set up user accounts. Consult the users or consult with users with programs in fourth generation languages. Extract data from organizational database onto personal computers. Answer basic on-demand questions. Provide a demonstration site for viewing hardware and software. Work with users to submit system change requests. Provide disaster recovery and backup. PC maintenance. Writing newsletters and offering types of proactive information sharing. Setting up user groups. Classic implementation mistakes. Using state-of-the-art technology because it increases time and cost estimates. Using low-cost personnel, lack of code control, use a source code library, or inadequate testing. Why implementation sometimes fails? Two conditions necessary for a successful implementation: management support of the system under development, involvement of users in the development process. Insights about implementation process. We have risk, commitment to the project, commitment to change, extent of project definition and planning, and realistic user expectations. For the implementation success of factors, we have extent to which system is used, user satisfaction with the system. For the extent of use, we have relevance to work performed, ease of use, reliability, user demographics, creative and beneficial use, and satisfaction. For project close down, We have evaluation team to reassign members to other projects. Notify all affected parties that the development project is ending and that you are switching to operation and maintenance mode. We have to conduct post-project reviews and close out customer contract as a formal sign-off. The process of maintaining information systems. Process of returning to the beginning of the SDLC and repeating development steps, focusing on system change until the change is implemented. We have four major activities. Number one, obtaining maintenance requests, transforming requests into changes, designing changes, and implementing changes. Maintenance or development, which would you choose? Maintenance reuses most existing system modules in producing the new system version. A new system is developed when there is a change in the hardware or software platform. The fundamental assumptions and properties of the data, logic, or process models change. Now let's proceed to code conducting system maintenance. For corrective maintenance, it fixes errors. For that, adaptive maintenance adds new capabilities and enhancements. Protective maintenance, it improves efficiency. Preventive maintenance reduces the possibility of future system failure. All maintenance has its costs. Many organizations allocate 80% of information systems budget to maintenance. Factors that influence system maintainability: latent defects, number of customers for a given system, quality of system documentation, maintenance personnel, tools, and well-structured programs. Measures of effectiveness. We have number of failures, time between each failure, type of failure, mean time between failures, a measurement of error occurrences that can be tracked over time to indicate the quality of a system. Controlling maintenance requests, it determines the type of request, for example, error, adaptation, and enhancement. For configuration management, we have the process of assuring that only authorized changes are made to the system. We have baseline modules where software modules that have been tested, documented, and approved to be included in the most recently created version of the system. System librarian, a person responsible for controlling and checking out and checking in of baseline modules when a system is being developed or maintained. Build routines, guidelines that list the instructions to construct an executable system from the baseline source code. And that's all for me. Thank you so much for listening.